Welcome back to Lesson 4 of the Unity Game Development Tutorial. In the previous lesson we looked at how to reposition a game object and how to make it move. We did this by changing the values of the transform of a game object. We started by changing the transform in the Unity editor and later using a script. This is a great way to make a game object move. But there are other ways to do this. In this lesson we'll learn about the way. By adding a rigid body on the game object, adding a rigid body component to an object. We'll put its motion under the control of Unity's physics engine. The rigid body component allows game objects to be affected by physics properties, such as gravity. It may sound a bit technical, but it is surprisingly easy to connect a rigid body to a game object. Let's open the Unity editor and place a sphere in the scene. We connect a rigid body component to this sphere. When we play the scene, we immediately see that the sphere is influenced by gravity. To prevent the sphere from continuing to fall, we can place a plane under the sphere on which the sphere can land. If we want to make the sphere move, we need to attach a script to it. Let's call this script movement. We start by declaring a public rigid body variable, which we call RB. Under the rigid body variable, we declare a public float variable force amount. We give the float variable a value of 100. In the update method we add a force to the rigid body with a vector 3.up. This will send the sphere into the air. We multiply the vector 3.up by the force amount variable. This way we can control the force. This is not a Star Wars reference. To give the rigid body variable a value, we drag the sphere game object in the Unity editor to the empty box behind RB. When we play the scene, we see the sphere shoot into the air. You can change the force applied to the sphere by adjusting the force amount variable in the editor. If, like in the previous lesson, we want to change the value of the x and z axis with user input, we can store it in a float variable. We use input.GetAxis to add the user input to the corresponding variable. So we have two float variables, one for the x-axis and one for the z-axis. We do not use the y-axis in this example. We create a new vector 3 variable called movement. We use both float variables in the movement variable. And then we replace the vector 3.up with the movement variable. This part is very similar to the way we used in the previous lesson to change the transform of a game object. Now we can control the sphere, but be careful. If you send the sphere outside the plane, it will fall off. When working with physics, it is necessary to have the physics calculations performed in a method other than update. Update is called at a variable rate. Depending on how fast the game is running, this is called the frame rate. FixedUpdate is called at measured intervals, meaning that FixedUpdate is called at a constant rate. The input checks take place in update. The physics-based movement calculations take place in FixedUpdate. There are a number of force modes. To apply a force to a game object, if you do not specifically apply one, the force is selected by default. This way the force gets applied continuously, building momentum and speed over time. If you want to add a force in a single burst, you can use the impulse force mode. This is useful for faster explosive movements, such as making a player jump. Let's add a jump function to our game object. First, we declare a new float variable for the y-axis. We take the user input value using input.GetAxis, between parentheses and quotation marks jump. Then we create a vector3 variable called jump. In update, we use the y variable to add to the jump variable. Here we leave the x-axis and the z-axis at 0. Finally, we use the jump variable to apply force to the rigid body. In this case, we use the force mode impulse. And we don't multiply the force by the force amount so as not to jump too high. And now we have a game object that we can control through user input. He can jump using the spacebar. The player can also jump in the air, not very realistic. We can do a collision test with the plane, so you can only jump when grounded. That's a great topic for the next lesson. In lesson 3, we control the game object by changing the transform. In this lesson, we control a game object by applying a force to it. At first glance, the results seem similar. The difference between the two methods becomes clear when I show both methods side by side. For this, I will first apply a material to the sphere. This is a topic that will be discussed in future lessons. I won't explain it in detail, but you can give a game object a different look by adding a custom material to it. You can clearly see that the transform method results in a sphere that slides on a plane, while the physics method ensures that the game object rolls over the plane. Another way to show the differences is when you see the interaction with other game objects. Please like and subscribe, so you'll get notified if a new video is uploaded. More people will get this video in their search result when they want to learn Unity game development. Thanks for watching. In the next lesson, we'll learn about collision detection in combination with the Unity physics system.